Have you ever been scrolling through engineering forums or job sites, seen the title Systems Engineer, and just thought, what do these people actually do? You're not alone. It's got to be one of the most debated and, let's be honest, misunderstood roles in the entire field. So today, we're going to pull back the curtain and get to the bottom of it. Okay, let's dive in.
So yeah, this is the big question, right? It gets posted online all the time. You've got design engineers, software devs, even project managers, all trying to pin down what a systems engineer really contributes. And the answers you find, well, they can get a little cynical.
I mean, you see comments like this one. It makes the role sound like it's just administrative work, just ticking boxes. That term, doors monkey, by the way, refers to a specific piece of software for managing requirements. And trust me, it is not a compliment. And then you get this take that they're basically just assistants for the project manager, chasing people down for deadlines to plug into a PowerPoint presentation. The idea is that they don't add any real technical value themselves.
This one really gets to the heart of the frustration, doesn't it? From the outside, it looks like a job that's just totally bogged down in pointless word games. And yeah, arguing over should versus shall sounds super trivial. But here's the thing. In a contract worth millions of dollars, shall is legally binding. It must be done. Should is just a goal. Getting that one word wrong can literally cause a mission to fail. But is that the whole job? No way. Not even close. So let's just reframe this whole thing. Forget the spreadsheets and the word choices for a minute. Picture a massive, complex project. Think of it like an orchestra. You've got all these brilliant specialists, the violinists, the percussionists, the woodwinds. They are absolute masters of their own instruments. But without a conductor to bring them all together, you don't get a symphony. You just get a bunch of noise. The systems engineer, they're the conductor. And to really get a sense of the sheer scale they're managing, one person online put it perfectly. Think about building an aircraft carrier. We're talking millions of individual parts and subsystems. The systems engineer is the one running the processes that make sure every single one of those pieces fits and works together flawlessly. And hey, if you want a more formal take, we can just look to NASA, an organization that probably knows a thing or two about complex systems. They call it a robust approach to the design, creation, and operation of systems. It's about figuring out the goals, picking the absolute best design, and then verifying that the whole thing comes together exactly like it's supposed to. The key takeaway here is it's a discipline. It's a structured process. So what does that process actually look like on the ground? It's not just one thing. The role actually changes throughout a project's life, which we can basically break down into 4 key phases. First up, you've got systems analysis, where you break down the big picture problem. Then comes systems design, which is all about creating the blueprint. After that is implementation, where they're working with all the other teams to actually build the thing. And finally, testing and validation to make absolutely sure it all works like it's supposed to. So let's see how this plays out in the real world. This isn't just theory. Just listen to Twet Hang Schnell, a systems engineering lead. She said that in the design phase, her job was incredibly specific and absolutely critical. She personally designed the startup module for a GPS satellite. This is the moment where those high-level requirements become a concrete, physical plan. Then, during implementation, the role kind of shifts gears. It becomes all about collaboration. Like she says, she works with the software engineers. She's not sitting there writing all the code herself. She's more like the guide, the translator, making sure the technical build-out actually matches the architectural vision. And this really shows you the final payoff. The job isn't over until the system is actually working for the person who's going to use it. For her, that meant getting on a plane and heading out to a military ship or aircraft to install, test, and even train the crew. That's that amazing moment where all the planning and all the meetings become a real, functioning thing. Okay, so we've talked about what they do, but what kind of person actually thrives in a role like this? It turns out it takes a really specific way of thinking, a mindset that's pretty different from other kinds of engineering. Here's the core difference. A component engineer, they're laser-focused on optimizing one single part and making it absolutely perfect. A systems engineer, though, is focused on the bigger picture. Their goal is to make sure all those perfectly designed parts actually play nicely together. They're responsible for the connections, the interfaces, those in-between spaces where projects so often fall apart. And according to NASA, you need a pretty unique set of traits to prevent those failures. You have to be able to see that big picture and understand how everything connects.
You have to be okay with uncertainty because you're often working at the very beginning of a project when nothing is clearly defined. And maybe most importantly, you need a ton of intellectual curiosity and amazing communication skills to be the bridge between all the different specialist teams. And these aren't just buzzwords for a resume. You're seeing those traits in action right here. This is the incredibly detailed, high-stakes work of making sure every single component on a satellite fits together perfectly, because once that thing is in orbit, there are absolutely no do-overs. So let's bring this all home. We've cut through the stereotypes. We've looked at the process. We've talked about the mindset. So why is this role so critically important, really? It's because they are the ultimate integrators. They're the translators who can speak the language of mechanical engineers, electrical engineers, and software engineers. They are the problem solvers who live right at the intersection of all these different disciplines, making sure the left hand always knows what the right hand is doing. So I'll leave you with this one final thought. From self-driving cars to spacecraft that are going to other planets, our technology is just getting more and more complex, with more specialized parts than ever. The question isn't whether we need people who can build all the individual pieces. The real question is, who's going to be there to connect them all?